All right, so 1, 2, 3 is where we're at right now, quadratic structure equations. Hopefully you understand how everything's built in this unit. So we have complex numbers, we had to simplify them. And the reason why we had to simplify them was because eventually your answers come out with complex solutions, and sometimes you have to simplify those quadratic answers, those solutions for the quadratic equations. The expressions is just one extra step where after you find the solutions, you just put it in factored form. Hopefully the practice problems weren't too rough. Today, we're going to go on to quadratic structure equations, which are basically equations that look like they're quadratic. So since they look like they're quadratic, you can literally use that fact to use a quadratic formula to solve them, because they kind of look like they're quadratic, even though they're not, technically. Structure equations. So it says right here, sometimes in math, let's do this. So it says sometimes in math there are problems that cannot be solved unless those problems are transformed and solved in a way that can work. Okay, so you're going to see a question where you cannot solve it, so we're going to turn it into a quadratic looking equation. That's why it's called quadratic structure, and then use quadratic formula to solve it. That's the moral of the story here. And what a quadratic structure equation looks like, the main thing that you have to see here is that this middle term, the power from it, if you double it going this way, so it goes from n to 2n, it's automatically quadratic in structure. Okay, so you're looking for that double. And it's pretty obvious most of the time when that happens. And essentially what you're doing when you double it is you're going to eventually be substituting in for u, and then it actually looks like a quadratic equation, and then you can use quadratic formula to solve. Okay, so that's kind of like the spoiler for it. But let's look at some examples right here to kind of make sense of this. So just look at part A here for now. Actually, hold on. I put it up here so it's just by itself. There we go. Now, if you notice, you might look at this and go, whoa, we never learned how to solve these. That's true, you never did. But the one thing I want you to see is this thing, if you double it to go over here, it doubles. So if you double 1/3, you get 2/3. Okay? 1/3, 2/3, it should be obvious that it doubles there. Okay, so when that happens, what you can do is you can use substitution to turn this whole thing into a quadratic structure equation and solve it. Okay, so that's what we're going to do. First of all, write this equation down because we're going to solve this problem together. So step 1, write it down. Also understand that it doubles. You're looking for that pattern for each of these problems. And so when you see it doubles, I want a light bulb to go off in your head and go, oh, this is quadratic structure. I know what to do. And then we're going to be doing the following steps right here so you understand. Okay, so we need to turn this into a quadratic. It's quadratic structure. We're going to turn it into quadratic. And to do that, what we're going to do, and usually books use u, so I'm going to use u as well, just in case someone like goes online and tries to find other problems that are like this, or maybe you watch a video, they have u in them. I use u in all my videos as well for this. But what we're going to do is our u is going to be equal to x to the 1/3. So your u is always equal to that middle term every single time. Oops. So this right here is going to be your u. Now watch this. What you can do here is you can rewrite this to be 2u squared, because technically u squared is equal to x to the 1/3 squared. And x to the 1/3 squared is equal to x to the 2/3. So this u squared right here, I'm going to try to color code it. This u to the 2/3 power can be also written as 2u squared. Then we're going to subtract 9u, because this part right here is equal to u. And then we're going to do plus 4 is equal to 0. So if you notice, now we have a quadratic equation. Now you can do what we did in intermediate algebra and what we did in the last section. You can just use quadratic formula for this. But you had to transform the original problem into be quadratic so you can actually solve it. All right, so let's keep going with this. We're going to use quadratic formula for this, only it's going to be u instead of x that we're solving for. So it's going to be u is equal to negative b, which is going to be negative 9, plus or minus the square root of b squared, which is negative 9 squared, which is just 81, minus 4ac. So it's going to be minus 4 times 2 times 4. Because if you can see here, this is our C, this is our A. And then we're going to divide this by 2a, which is 2 times 2, so it's 4 here. Let's simplify this down here. This becomes 9. So it's 9 plus or minus. 81 minus 32 is 49. Yes? No?
Yeah.
Yes? Always assume you're wrong. We're going to do, this is going to be 9 plus or minus 7 over 4 because this just becomes 7. All right, so we're going to do the plus version first. So it's going to be 9 plus 7 is 16 over 4. That's one of the answers. Then we'll do the minus version, which is going to be 2 over 4. So now you have 2 answers for u. So this is 4, and this is 1/2. So you have 2 answers for u. The problem is, if you look up here, well, actually, it's not a polynomial. That's not really a problem. The issue is that the problem starts in terms of x, and we have our answer in terms of u. You can't do that. You have to answer it with whatever the variable starts with. You can't just say u is equal to 4 and 1/2 and call it a day. You have to look at the original. It goes up. There's x's, so we have to answer in terms of x. Does anybody know how I can get that final answer to be in terms of x? It's okay if you don't. Well, u is equal to x to the 1/3. So what I can do is say u is equal to 4. U is equal to 1/2. And then you can go, well, u is also equal to x to the 1/3. Hold on, I feel like this would show. U is equal to x to the 1/3. So that's equal to 4. And then this u is equal to x to the 1/3. And that's equal to 1/2. And now you can just solve from here. And then you'd be solving for x. So to get rid of the 1/3 power, you have to cube it. Cube this, cube this, cube that. Okay, this cancels. So now you're left with x. 4 to the 3rd is 64. This cancels. And then 1/2 to the 3rd is 1/8. Okay. And then you want to like check your work on that by just throwing it into the original. You should get 0, but we don't need to waste time with that right now. And you get your answers. Are there any questions on this? Okay, so as you can see, it's still using quadratic formula, which you did in intermediate, you did it in this class, you did it in the previous section. I think you might have even done it in algebra. But we're doing it one extra layer of this u. So this u step is really the one extra thing on it. Okay. All right, let's do another one. Why is... I don't know why I put that one there. It's not like, that's not a quadratic structure. That's kind of embarrassing. All right, let's do C here. You'll notice, again, a light bulb should be going off in your head whenever this happens. This and this, if you double this first one right here, it's to the 4th. So whenever you see that pattern, then you know that you can do quadratic structure solving. The main thing with this one, though, is you do need to put it all in standard form. So we do need to move this 5 to the other side. Okay. So first thing we're going to do is we're going to add 5 to both sides. So cancel, cancel, and then you're going to be left with 0 is equal to 3x to the 4th minus 16x squared plus 5. Okay, it's still a quadratic equation, but it has to be set equal to 0 in order to solve it. The next step is to find your u. Your u is always that middle term's x, whatever this is right here. Okay, the other one was x to the 1/3 because it was that middle term. Right there was that middle one. Whatever you don't double, or whatever you would have to double, I should say. It's always that middle one. All right, so now what we're going to do is we're going to rewrite that orange equation. So now it's going to be 3u squared minus 16u plus 5. Now it's a standard problem that you've done in the past. Okay, use quadratic formula. So you're going to be left with u is equal to negative b, which is negative 16. So I'm just going to write positive 16, plus or minus the square root of b squared. So that's 16 squared. I think that's 256. 256 minus 4ac, which is 60. And then we're dividing all this by 2a, which is 2 times 3, to be 6. Okay. Everyone following along okay here? All right. From here, this ends up being 196. So you have u is equal to 16 plus or minus the square root of 196 all over 6. I believe the square root of 196 is, 14. Okay. So this is equal to 14. So now you're left with 16 plus or minus 14 divided by 6. So this means we have 2 over 6 for the minus and 30 over 6 for the plus. So we have u is equal to 1/3 and we have u is equal to 5. Okay. Now, based on the fundamental theorem of algebra, we should have 4 answers because the degree is 4. So this is only 2 answers, and the reason it's 2 answers is because really we're solving for u and we should be solving for x squared, or for x, I should say. So that's what we're going to do next. This u is equal to x squared, so I'm going to say x squared is equal to 1/3, and then this is x squared is equal to 5. Then when we do the square root, you'll have 4 answers because we're going to do the square root here, plus or minus, so that's 2 answers. We're going to do the square root here, which is another 2 answers, so you have 4 answers total. Cancel, cancel. X is equal to plus or minus the square root of 1/3. And then this one, cancel, cancel. X is equal to plus or minus the square root of 5. Okay.